We've had a lot of questions on the channel over the past couple of months, and we thought it'd be a good idea to just go through some of those and answer some of the things that are on your mind. A lot has been happening over the last couple of months, and sometimes we're not so good at describing everything that's happening inside of the program and what we're up to and the reasons why we're doing certain things. So we thought it'd be a good idea to kind of go over some of those questions that you guys are having and address them in a more detailed way. So without further ado, let's get into it. First up, we have one of the most commonly asked questions, which is actually just about what Astra is in the first place. We can kind of see where this confusion comes from because there are a lot of companies that have Astra in their name. For instance, there's a beer company which is called Astra, but of course we're not associated with that. There's also a car company which makes a model called an Astra. We're not making any cars, so again, no association. But most confusingly, there's actually a rocket company in America which builds rockets for the small sat launch market, and they're also called Astra. But again, this has nothing to do with our group, which is called Astra. We're a student group which exists in Bremen, which is specifically designing a rocket which will go to the Kármán line. So nothing professional to do here. We're not building anything for like commercial industry or anything. We're just a student group. And yes, this is our official channel. So the question being, is this our official channel? Well, yes, it is.
Well, no fucking shit!
But it might not be for the Astra that you were thinking of, so.
These aren't the droids you're looking for.
These aren't the droids we're looking for.
If you're here to watch students build a rocket that goes to space, then you're in the right place. How do you join the University of Bremen, and what is the eligibility in order to join Astra? Well, the University of Bremen is the university which most of the body of Astra actually comes from, and it's a university which is located inside of Germany, and there are some things that come with that. For joining the university, there are actually many different criteria, depending on the field that you want to go into. So there aren't really that many English programs that are at the university, so typically you'll usually have to speak German in order to take the classes.
Obviously.
There are some exceptions, of course. So in the Space Engineering Master, which I'm in, it's actually an English Master. And if you're going into a Master's, there are actually lots of other English programs that you can kind of choose from. But in the Bachelor, there's kind of less English that's available. So depending on where you are in your education, it'll determine what your requirements are in terms of language. But overall, you will need to speak some German because, of course, it's in Germany and you'll have to live in Germany. So for our program, there's actually a requirement that you have to speak at a B1 level in order to join the space engineering program. But it'll be different for each of the programs that are available at the University of Bremen. Of course, there are also some other requirements in terms of classes you've taken and prerequisites. So you definitely have to check the university website to see what the requirements are for you. And yeah, I'll post a link in the description. But of course, the next part of the question, which is the eligibility to join Astra. Right now, just to be clear, there's really only two eligibility requirements. The first requirement being that you must be a student. So not necessarily a student of the University of Bremen. There are multiple universities within the Bremen area, which would definitely suffice as being a place that you could join Astra from. We have a couple of students who come from different universities, so that's also not really much of a problem. The second part is that you have to reside within the Bremen area. So in order to participate in the group activities and build the parts and go to the labs, you of course need to be within the Bremen area. In terms of prerequisites of things that you need to know before you join Astra, there aren't really any. There are many, many different things that you can do within the Astra group. It's not just engineering. We have a marketing team, we have a project management team, we have a legal team. So there's really all kinds of fields that you could get involved with. Building a rocket is a very complex endeavor and requires lots of different skills in order to get it actually done. So this is really embodied in who is participating in Astra and where you can contribute to the Astra community and the Astra group. Right now, we're specifically looking for more help in our marketing and project management sides of the operation. So if these things are looking interesting to you and you want to participate in marketing a rocket or project management for a rocket, then maybe consider getting involved. We're looking forward to having you. Next up, we have some more specific questions about Transcendence, which is the rocket that we're building in order to go to space, and also the testing apparatus that we're using to test various parts of the rocket. So how do we determine the shock loads of our Guillotine test setup? So the Guillotine is basically this device that we built in order to generate shock loads that we could use to test structures on our rocket. Specifically, we've been using this apparatus in order to test the recovery bay to make sure that it has the structural integrity to survive the deployment of the parachutes. If you want to see this testing in action, be sure to check out our video which goes into how we built the stand and the testing that we did on it. But one thing we didn't really address clearly is how we determine the shock loads on this Guillotine setup. And here we have Tomek, the test stand designer, in order to tell you a little bit about how that works. So basically we have position data with the camera.
Yeah.
And then the program is going to do a double derivative
Yeah.
of the position
Yeah, exactly.
to find out the acceleration.
Discrete derivative, basically. It will you define basically with a stick. 10 pixels are 0.1 meter.
Yeah.
And then basically the program can calculate the position of each tracked frame, and then it will say subtract the frames and divide it by the FPS, so the sample time.
So it gets the idea of how far it's moved per second.
Exactly.
And then from there it
Like,
takes the discrete derivative to find the acceleration.
So basically it it calculates the distance, and now you know you have 120 FPS, so 1 divided by 120 time the distance divided by 1 divided by 120, so times 120.
Mm-hmm.
And so it does the discrete derivative. Yeah.
Okay.
And the same for the acceleration then. And from that we basically multiply the acceleration with the mass to get the force.
Next up, we have a technical question for the structures group. What are the pockets on Transcendence's middle bulkhead for? So in some of the 3D animations for our structures video, which you can also see up here, we had basically these pockets that were built into our middle bulkhead. And I guess they kind of look interesting and maybe a little bit cool. So people had some questions about them. Basically what these are for are to provide an area where we can put valves and sensors onto the rocket. Each of these pockets has a channel which connects to the main flow conduit of the nitrous oxide into the combustion chamber. Remember that our rocket is a hybrid rocket, so basically we have a fluid nitrous oxide which is contained inside of the oxidizer tank, and that has to flow into the main combustion chamber via some sort of flow conduit. So basically these 4 pockets are all connections to that main flow conduit, where we can put things like our filling valve and our relief valve, as well as our sensors like pressure sensor, temperature sensor, etc. And we can get data on how our rocket is behaving. This is maybe a little bit different from how other rockets design their plumbing. However, we wanted to have a design which incorporated the structural elements, so basically a place where we can connect our tubes, as well as incorporating all of those plumbing logistics. So it's kind of one simple part that we can just incorporate, and it's really easy to assemble. So we're hoping that we have some advantages in this area. But of course, we'll all know if this is actually working when we do a pressure test to see if this actually works. And that pressure test is coming up, so stay tuned. Next up comes the real hard question. How much does a rocket like Transcendence cost? Of course, in any sort of engineering endeavor, there's always going to be costs associated with that, and rockets are certainly no exception. Rockets are actually particularly quite expensive, I would say. So to build a rocket that goes to the carbon line, you first have to think about the cost of the actual physical structures of the rocket itself. So this is things like the aluminum you're going to use, the carbon fiber, etc. For our rockets, we have a really big rocket we're building. It's going to be 250 millimeters in diameter and over 6 meters tall. So you have to think about like all the carbon fiber and aluminum that's going to go into that to actually build that structure. And yeah, after you do all the calculations and you figure out what it is, it's probably going to be around like 5,000 euros in terms of just the cost of the raw materials. We're a little bit unique in that we're actually getting to have the machining of those materials and the manufacturing of those materials mostly done for free. So we're building our own carbon fiber tanks, so we don't have to worry about the labor cost. And there's a company sponsoring us for the aluminum bulkheads, so also we don't have to worry about the labor cost involved there as well. Then you have to think about all of your other structures that you're building inside of your rocket, things like the nozzle and the injectors and valves and all these things that are not obvious when you first look at the rocket, but come up later on. These also tend to be a little bit expensive because they need to be precision machined and they need to have special processes that are involved in making them. But in total, all those little secondary structures, I can call them, probably going to put you in the 5,000 to 10,000 euro range as well. And that's just for one vehicle that you want to build that would potentially be able to go to space. So if you look at this on the surface, it seems like, oh, the rocket will only cost like 15,000 euros. A mistake that I made early on.
No, it's false. Not this time.
But actually, you aren't just building one rocket. You have to build a whole testing campaign to develop the rocket, because you have an idea of what the rocket will do in your mind and on paper, but what it actually does in reality is maybe something completely different. So you have to test these things to make sure that you're building what you want. Otherwise, you'll build the whole rocket for 15,000 euros and you'll go to the launch site and it'll just blow up. So when you think about the structures of the rocket and things you're doing and things you're building, you have to think about it in terms of building enough of them that you have enough material to test and make changes and then test again.
A high production rate cures many ills.
So we're going to be testing Transcendence through various different iterations. So first we're going to build like a small scale version of Transcendence, which is we're calling subscale for now. And we're going to go to the propulsion test stand and basically static fire this thing probably 5 or 10 times at least, just to make sure that we kind of understand the physics of the hybrid propulsion. So we have to think about like, okay, we have to build that stand. We have to build the structures to make that stand. We have to fuel that stand, so paraffin wax plus nitrous oxide. And then you have to think about that for every single test that you're going to do on the rocket. It's not just propulsion. You have to think about that for aerodynamics tests, if you're going to do that in a wind tunnel, or for shock testing of the recovery bay to make sure it can withstand the shock test of the parachutes deploying. Maybe a drop test you're going to do. So now you have to think about executing a drop test somehow with maybe a drone or a helicopter or a hot air, a helium balloon, and you need a space for that, and then you might need money to clear that space, plus documents you need to submit to make sure that it's all compliant with the authorities. There's lots of extra little things that come up in terms of cost that contribute to the cost of the rocket in the end. It's not just the cost of the physical rocket itself. Anyways, that's kind of a long way of describing how costs build up, I guess, in a project. Overall, though, we've done some initial cost models with the information that we have right now about how much we expect the rocket and the program to cost. And we expect it's going to be around 100,000 euros to develop the rocket and build the rocket and have a rocket that's ready to work. And then you actually have to launch that rocket. And usually the launch sites, based on the way that we've been discussing costs with the launch sites that we've talked to so far, it's usually going to cost at least 100,000 euros in order to get a launch that goes up all the way to the Kármán line to actually work. So in total, long answer, short, the total program is probably going to be around 200 to 250,000 euros in terms of the cost. So that's the cost of building a rocket in Europe and sending it to the Kármán line. And I should note, I put a star beside that number because in most cases, we've been told that that number is far too low. However, we are really trying to do our best in order to minimize the cost of our rocket, and we've really picked a design that we think will best reflect the lowest cost that we can have for our rocket. Of course, because the hardest thing to do in any rocket program is not necessarily to do the rocket engineering, but it's actually to find the money to actually build a rocket. We're basically trying to just reduce that difficulty as much as possible. Anyways, apologies for the long answer on the cost. It's only the question that's been weighing on my mind the most out of all questions. You can help Transcendence get to its goal. We do need around 200,000 euros in order to make this project work, but you can help us out with that cost. We've left a link in the description, which goes to our PayPal portal where you can make a donation. Another way you can support the channel is to check out our merch store, where we have lots of interesting things like sweaters like this, which have our logo on it. We have sweaters, shirts, hats, bottles, all kinds of stuff. So if you're interested in, getting a cool logo, which is supporting a rocket group, definitely check out our merch store. If you have any lingering questions about Astra or the Transcendence rocket or what our group is all about, be sure to leave them in the comments. I read all the comments and I try to respond to as many as I can, and maybe your comment will be featured in the next video. And remember to expand your horizons.